Let us learn integration by parts. It is otherwise known as inverse of product rule because integration by parts formula is derived from product rule formula. The product rule formula is d by dx of f of x times g of x is equal to f dashed of x times g of x plus f of x times g dashed of x. This is product rule which we have learnt in differentiation lesson. Let us integrate both sides. Integration and differentiation will get cancelled. Therefore, the left hand side becomes f of x times g of x is equal to integral f dashed of x multiplied with g of x dx plus integral of f of x times g dashed of x and dx. Let us find this term. Therefore, integral of f of x into g dashed of x dx is equal to f of x into g of x minus integral f dashed of x times g of x dx. This is the formula of integration by parts, but this is so difficult to memorize. We will take this as the first function and this as the second function and write the formula as integral first function into second function dx is equal to first function. Here we have taken the first function as f of x and second function as g dashed of x. Therefore, the right hand side becomes first function into, here we have g of x, which is integral of the second function. Second function is g dashed of x. So, g of x will be integral of the second function minus integral differential of the first function, which is f dashed, and g of x is integral of the second function. This is how we get integration by parts formula. You need not learn the derivation, but I have taught you the derivation so that it will be easy for you to remember the formula, and you should know that this formula has been derived using the product rule of differentiation. This dx is for this integral and this dx is for this integral. Now write down this integration by parts formula in your formula notebook. When do we use this formula? When we have product of functions. Okay, we use this method. The formula is integral first function into second function dx is equal to first function into integral of the second function minus integral differential of the first function into integral of the second function. This integral of the second function is in both the terms. This is by parts formula. Memorize this formula. And then let us see how to decide which one has to be taken as first function and which one has to be taken as the second function. We follow this ILATE rule. Here I stands for inverse trigonometric function. L stands for logarithmic function. A for algebraic function. And T is for trigonometric function and E is for exponential function. So whichever function comes first in this ILATE, that should be taken as the first function, the other one as the second function. I will explain this when we do the questions. Now write down a note. if there is only one function which cannot be integrated directly, like integral of log x or integral of inverse trigonometric functions, sine inverse, cos inverse, tan inverse, etc., then 1 is taken as the second function. We don't know the integral of log function. We know only differential of log x. Similarly, we know only differentiation of inverse trigonometric functions. We don't have formulae for integral of log x and integral of sine inverse of x, etc. So in such cases, 1 is taken as the second function. So write down these points in your formula notebook. Exercise 7.6, question number 1. Integral x sin x dx. In ILATE, x is an algebraic function and sin x is trigonometric function. A comes first. So x is the first function and sin x is the second function. Write integration by parts formula. Memorize and write. First function into integral of the second function minus integral differential of the first function into integral of the second function. Let us apply this formula. First function is x and integral of the second function. Let us do the integration of these two directly and write. Otherwise, you will have so many integral signs. So integral of the second function, in most of the questions it will be easy. Directly we will be able to write. So integral of the second function is integral of sin x, which is minus cos x, minus integral differential of the first function. Differential of first function is x, differential of x is 1, and integral of the second function, integral of sin x is minus cos x, so plus cos x dx it becomes. I told you we will write these two integrations directly, so we will be left with this integral. Let us do that integration. Integral of cos x is sin x plus c. And note that when we do integral of this second function and this second function, no need to write plus c. Even if you write, those c's will get cancelled. So no need to write. Okay, let us write 1c at the end. Now second question, integral x sin 3x dx. It is a similar question. Algebraic and trigonometric function we have. X is the first function, sin 3x is the second function. Let us use by parts formula. First function into integral of the second function. I told you to write integral of the second function directly. Integral of sin 3x is minus cos 3x divided by 3. Don't forget to divide by the coefficient of x term, minus integral differential of the first function, which is 1, and integral of the second function. Integral of the second function is minus cos, so minus of minus plus, cos 3x divided by 3 dx. I told you no need to write plus c for these integral of second function terms. Finally, we will write 1c. Minus x by 3 cos 3x. 1 by 3 is a constant, it can be taken out. And integral of cos 3x is sin 3x divided by 3 plus c. Let us simplify the second term, and 3 3s are 9. It becomes 1 by 9 sin 3x plus c. Third question, integral x square e power x dx. Here x square is an algebraic function, e is an exponential function, e is the last letter. So always exponential function will be taken as our second function. Let us write by parts formula. Integral first function into second function dx is first function into integral of the second function minus integral differential of the first function into integral of the second function. Let us apply this formula. First function is x square. Integral of e power x is e power x minus integral differential of the first function. Differential of x square is 2x. And integral of the second function is e power x dx. And in this second term, 2 can be taken out and use by parts again. X is the first function, e is the second function. Use brackets because we are going to write two terms. First function into integral of the second function minus integral differential of the first function. This 2 has been taken out. Differential of the first function is 1 into integral of the second function dx. I told you we will write 1c at the end. X square times e power x minus 2x e power x. Minus of minus will become plus 2. Integral of e power x is e power x and plus c. E power x is common in the first three terms. Let us take e power x out. We get e power x times x square minus 2x plus 2 and plus c. Question 4. Integral x log x dx. ILATE. X is an algebraic function and log x is logarithmic function. The letter L comes first. So log x is first function, x is the second function. Let us use by parts formula. You write the formula and then apply it. First function into integral of the second function. Integral of x is x square divided by 2 minus integral differential of the first function. Differential of log x is 1 by x times integral of the second function dx. Let us simplify this. X square divided by 2 log x. Half is a constant. Take it out and integrate x. Integral of x is x square divided by 2. Therefore, the answer is x square divided by 2 log x minus 1 by 4 x square and plus c. Question 5, exactly the same type as the fourth question. We have algebraic function and logarithmic function. Algebraic and logarithmic. L letter comes first. First function, second function. ILATE is suitable for all questions, but few questions are there where we can interchange and take. We will be able to apply integration by parts method. But ILATE is suitable for all questions, I said. This is equal to, let us write integration by parts formula. Integral first function into second function dx is equal to first function into integral of the second function minus integral differential of the first function into integral of the second function dx. Let us apply this formula. First function is log 2x and integral of the second function, that is integral of x is x square over 2 minus integral differential of the first function, that is differential of log 2x. We have to use chain rule. First differentiate log, then differentiate 2x. Differential of log is 1 divided by 2x and differential of 2x gives you 2 into integral of the second function, which is x square divided by 2 dx. One x also could be cancelled. The second term is half into integral x dx. Therefore, the answer is x square divided by 2 log 2x. Integral of x is x square divided by 2. Already 2 is there in the denominator, so it becomes 1 by 4 and plus c. Question number 6. Integral x square times log x dx. Similar question, algebraic and logarithmic. Let us use by parts formula. You write the formula and then apply it. First function into integral of the second function. Integral of x square is x cube divided by 3 minus integral differential of the first function. Differential of log x is 1 by x into integral of the second function, which is x cube by 3. It becomes x square. X cube divided by 3 multiplied with log x minus 1 by 3 is a constant. Let us take it outside the integral. We have integral x square dx. X cube divided by 3 times log x minus integral of x square is x cube divided by 3. Already 3 is there in the denominator, so it becomes 1 by 9 and plus c. Question number 7. Integral x sine inverse of x dx. X is an algebraic function. Sine inverse of x is inverse trigonometric function. The letter I comes first. Therefore, sine inverse of x is the first function and x is the second function. Let us use by parts formula. Integral first function into second function dx is equal to first function into integral of the second minus integral differential of the first function into integral of the second function dx. You have to write 2 dx, I told you. This dx is for this integration and this dx is for this integration. Therefore, the answer is first function, which is sine inverse of x, into integral of the second function, which is x square divided by 2 minus integral differential of the first function. Differential of sine inverse is 1 by root of 1 minus x square into integral of the second function, which is x square divided by 2 dx. We can use substitution method here, or we may add 1 and subtract 1. So the first term is x square by 2 sine inverse of x. Half is a constant, take it out. We have x square divided by root of 1 minus x square dx. Since we have minus x square in the denominator, let us write minus x square here. So this becomes plus. Now add 1 and subtract 1. Equal to x square divided by 2 sine inverse of x plus half into integral. Let us split this into 2 integrals. The first term will be 1 minus x square divided by root of 1 minus x square. So root could be cancelled. It becomes root of 1 minus x square. And the second term is 1 divided by root of 1 minus x square dx. We have direct formulae for both, but this formula we are going to learn in the next exercise. So we will use that formula here. I am writing that formula. Integral root of a square minus x square dx is x divided by 2 root of a square minus x square plus a square divided by 2 sine inverse of x by a plus c. This formula can be written in terms of sine inverse of x by a, or in terms of cos inverse also it can be written. But if you use cos inverse, this sign will be negative. It will become minus a square cos inverse of x by a. Because we have a formula, no? Sine inverse of x plus cos inverse of x is pi by 2. Using that, we can change this formula and write it in terms of cos inverse. x square divided by 2 sine inverse of x plus half into, let us use this formula, a here is 1, x by 2 root of 1 minus x square plus a is 1, sine inverse of x, and integral of this term is sine inverse of x plus c. These two are like terms. X square divided by 2 sine inverse of x. Let us distribute this half. So x by 4 root of 1 minus x square plus half minus 1 will become minus half, and multiply it with this half, so it becomes minus 1 by 4 sine inverse of x plus c. We can combine sine inverse of x terms, therefore the answer will be 1/2 is common, sine inverse of x is also common. We get x square from the first term and minus half from the second term. And the other term is x by 4 times root of 1 minus x square and plus c. Next question. Integral x tan inverse of x dx. I comes first in ILATE. Tan inverse of x is the first function and this is the second function. And by parts formula is this. Let us use this formula. First function is tan inverse of x. And integral of the second function, integral of x is x square divided by 2 minus integral. Differential of the first function. Differential of tan inverse is 1 by 1 plus x square. You should be thorough with all differentiation and integration formulae. Integral of the second function is x square divided by 2 dx. Half is a constant, take it out. Here also we will add and subtract 1, or here degrees are same. We have to divide, long division method, and write it as quotient plus remainder by divisor. But it will come to the same step as adding 1 and subtracting 1, even if you do long division method. Add and subtract 1, which is equal to x square divided by 2 tan inverse of x minus half into, let us separate the terms, 1 plus x square by 1 plus x square is 1, minus the second term is 1 divided by 1 plus x square times dx. Now easily we can integrate these two terms. Minus half into, integral of 1 with respect to x is x, and integral of 1 divided by 1 plus x square is tan inverse of x plus c. Now we will combine tan inverse terms. Half is common, tan inverse of x is common. We get x square from the first term, and this is minus into minus plus half. Half is taken out, so it becomes plus 1 minus half x and plus c. Question number 9. Integral x cos inverse of x dx. In ILATE, I comes first. So inverse trigonometric function is always the first function and x is the second function. Write by parts formula. Please memorize the formula and write. Don't copy the formula. Apply this formula. First function is cos inverse of x into integral of the second function. Integral of x is x square divided by 2 minus integral. Differential of cos inverse is minus 1 by root of 1 minus x square. And integral of the second function, which is x, integral of x is x square divided by 2 dx. X square by 2 cos inverse of x minus half is taken out. Denominator has minus x square and numerator also has minus sign. Add 1 and subtract 1. This is equal to x square divided by 2 cos inverse of x minus half into, split this into two terms. 1 minus x square divided by root of 1 minus x square becomes root of 1 minus x square, and the second term is 1 divided by 1 minus x square into dx. Let us use this formula. I told you that this formula is given in the next exercise, which is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a and plus c. This formula can be written in terms of cos inverse also, but you will have minus sign here. If we write the formula in terms of cos inverse, it will be x by 2 root of a square minus x square minus a square by 2 cos inverse of x by a. Using the identity sin inverse of x plus cos inverse of x is equal to pi by 2, we can change sin inverse to cos inverse, and pi by 2 and this c can be combined as some other constant. So we may write the answer in terms of cos inverse also. Therefore, the answer becomes x square divided by 2 cos inverse of x minus half into x by 2, a is 1 here, so root of 1 minus x square minus 1 by 2 cos inverse of x, and integral of minus 1 by root of 1 minus x square can be written as cos inverse of x. Or you may write minus sin inverse, but all terms are in terms of cos inverse, so I am writing in terms of cos inverse. That is minus 1 by root of 1 minus x square. This is cos inverse of x because of this minus sign. So that we can give the answer in terms of cos inverse throughout. X square divided by 2 cos inverse of x minus x by 4 times root of 1 minus x square, and this is plus half cos inverse. We have minus half outside, so minus 1 by 4 cos inverse of x plus c. Let us combine cos inverse of x terms. Half is common, cos inverse of x is common. We have x square from the first term and minus half from the third term. Then write the middle term here and plus c. This is the answer. Or you may give the answer with first term in terms of cos inverse of x and other two terms in terms of sin inverse of x. Question number 10. Integral sin inverse of x the whole square dx. Let us use substitution. Two methods are there. Directly you can take it as 1 into, and 1 can be taken as the second function and this as the first function, or we may use substitution. I will take sin inverse of x as t. X will be sin t. Now differentiate. Differential of sin is cos t dt. If you differentiate directly like this, you will get 1 by 1 minus x square, which is not there in the function. That's why I wrote x as sin t and differentiated. Otherwise, if you differentiate sin inverse, again you have to substitute. This is equal to integral. This becomes t square and dx is cos t dt. Now let us use by parts formula. First function into integral of the second function minus integral differential of the first function into integral of the second function dx. In ILATE, T square is algebraic and cos is trigonometric. A comes first. T square is the first function, cos t is the second function. First function into integral of cos t. Integral of cos t is sin t minus integral. Differential of the first function is 2t and integral of the second function is sin t. We have to use by parts method again. But in the first step we had t square. Now we have only t. The power has been reduced. Algebraic function is the first function and sin t is the second function. 2 times first function into integral of the second function. Integral of sin is minus cos t minus integral. Differential of the first function is 1. Integral of sin t is minus cos t. So minus of minus is plus. T square sin t. Let us distribute this minus 2 plus 2t cos t minus 2 times integral of cos t is sin t and plus c. Now look at our substitution. X is sin t. So change all other trigonometric functions which are in the answer in terms of sin t. Remember, any trigonometric function can be written in terms of any other trigonometric function. We have cos t. I can write cos t as root of 1 minus sin square t. Use the identities so that it is easy for me to substitute for sin t. Minus 2 sin t plus c. Or you could have written it as cos of t is sin inverse of x, but this is not in the simplest form. Okay, you can simplify this function. That's why I told you to change cos t in terms of sin and then substitute. So directly you will get the simplest form. And here t is sin inverse of x. T square will be the whole square. Sin t is x plus 2. T is sin inverse of x. And this becomes root of 1 minus x square minus 2x and plus c. This is the answer. Question number 11. Integral x cos inverse of x divided by root of 1 minus x square dx. Here we have 3 functions. Let us go for substitution. We will take cos inverse of x as t. Differential of cos inverse is minus 1 by root of 1 minus x square dx, which is dt. Here I didn't write x as cos t as I did in the previous question because already I have this function. The differential of cos inverse is there in the function. That's why I didn't change. From this equation, x is cos t and cos inverse of x is t, and dx by this becomes minus dt. There is a minus sign which can be taken out. Integral t cos t dt. Use by parts method. ILATE. T is algebraic, cos is trigonometric, A comes first. Let us write the formula. First function into integral of the second function minus integral differential of the first function into integral of the second function. I am saying this and writing so that you memorize it. Therefore, it becomes, there is a minus sign, so use brackets. First function into integral of cos t, which is sin t, minus integral. Differential of t is 1 and integral of cos is sin dx minus t sin t plus integral of sin is minus cos t. Let us substitute for t. Look at the substitution cos t. So change this sin t in terms of cos using the identity, which is 1 minus cos square t minus cos t and plus c. Now let us substitute. Minus t is cos inverse of x into root of 1 minus cos t is x, so it becomes x square. See this step. Minus cos t is x and plus c. Question number 12. It is an easy question. ILATE. X is algebraic and secant square is trigonometric. The letter a comes first, so x is the first function and secant square is the second function. By parts formula, integral of first function into second function dx is first function into integral of the second function minus integral differential of the first function into integral of the second function dx. Let us use this formula. First function is x and the second function, integral of secant square is tan x. We have direct formula for this. Minus integral differential of x is 1 and integral of secant square is tan x dx. X tan x minus integral of tan x has two formulae, log of absolute value of secant x or minus log of absolute value of cos x. So minus and minus is plus log of absolute value of cos x plus c. This is question number 12. Now 13th question. We wrote a note. If there is only one function which cannot be integrated directly, like log function or inverse trigonometric function. Here we have only one function which is an inverse trigonometric function. We don't have direct integration formulae for inverse trigonometric functions as well as log function. In such cases, we take it as 1 into, and this 1 should be taken as the second function and this is the first function. I comes first. 1 is an algebraic function. Constant terms come under algebraic function. Integral of first into second dx is equal to first function into integral of the second function minus integral differential of the first function into integral of the second function dx. Hope you have memorized this formula. First function is tan inverse of x. Integral of 1 is x minus integral differential of tan inverse is 1 divided by 1 plus x square into integral of the second function. Integral of 1 is x dx. This is easy. By substitution we can integrate because differential of x square gives us x term. Differentiate 2x dx is dt. Therefore x dx is dt divided by 2. X tan inverse of x minus x dx is dt divided by 2 and the denominator is t. X tan inverse of x minus integral of 1 by t is log of absolute value of t and plus c. Let us substitute for t. Log of 1 plus x square is positive. X square is positive and we have plus sign, so I need not write the absolute value sign. Question 14. Integral x times log x the whole square dx. X is an algebraic function, logarithmic function. L comes first. This is the first function and this is the second function. Write by parts formula and use it. First function, into integral of the second function, which is x square divided by 2 minus integral differential of the first function. We have to apply chain rule. Power has to be differentiated first, so 2 times log x into the base. Log x has to be differentiated. So it is 2 times log x into 1 by x into integral of the second function, which is x square divided by 2 dx. X square divided by 2 log x the whole square minus integral x log x dx. Before the power was 2 log x the whole square, now the power has become 1. Let us use by parts method again. L comes first function and second function. First function into integral of the second, which is x squared by 2 minus integral differential of the first function. Differential of log x is 1 by x into integral of the second function, which is x squared divided by 2 dx. Distribute this negative sign. Minus into minus is plus. Integral of x is x square divided by 2. Already 2 is there, so it becomes 1 by 4 x square and plus c. Question 15. Integral x square plus 1 times log x dx. Similar question, algebraic function and log function. Letter L comes first. Write by parts formula and then use it. First function into integral of the second function. Integral of x square is x cubed by 3 plus x minus integral differential of the first function, which is 1 by x, and integral of the second function, the same thing, dx. Let us distribute. It becomes x square by 3 and 1. The integration is 1 by 3 times integral of x square is x cubed by 3 and 3 3s are 9, and distribute this negative sign, minus 1. Integral of minus 1 is minus x and plus c. Let us do example 18. Integral of log x dx. We wrote a note. If there is only one function like log or inverse trigonometric function, we take it as 1 into, and that 1 should be considered as the second function and log x is the first function. Let us use by parts formula. Write the formula and then use it. First function into integral of the second function. Integral of 1 is x minus integral differential of the first function. Differential of log x is 1 by x into integral of 1 is x. X log x minus 1. Integral of 1 with respect to x is x and plus c.